우리 몇 분 기다리고 나중에 시작하자.
네.
지금 시작해보자. 다들 숙제 끝냈어?
네, 끝냈습니다.
자, 우리 먼저 숙제 한번 봐보자. 숙제 괜찮았어? 너무 어렵거나 그러지 않았어?
조금 어려웠어요.
저도요.
그래. 뭐가 제일 어려웠어? 다 어려웠나? 일단 해보자. 1번부터 simplifying roots of negative numbers. 자, 1번. 이거 지원아, 너부터 시작해볼까?
네. 풀이 과정도 말할까요?
아니야, 일단 답만 알려주면 될 것
I wrote 2i
같아.
and root 5.
2i root
Then,
5, like
yeah.
that. Okay, did anybody else get a different answer? Everybody got that?
I got that also.
Okay, nice. So if everybody got that, we're gonna move on. The next question is positive, negative, square root of negative 48. 살리나, 너가 해줄 수 있어?
Yep. 4i square root 3.
4i square root 3.
Yep.
Everybody got that?
Mm-hmm.
Right? Okay, let's move on then. The next question is plus or minus square root of negative 38. 시우야, 이거 해줄 수 있어?
I root 38.
I root 38, right? So that should be your answer. You can't simplify that into another number, so that should be right. Moving on, powers of the imaginary unit. We have I to the 73rd power. 민혁아, 이거 풀었어?
네.
답 뭐 나왔어?
답 그냥 I.
I?
네.
I 맞지? 다들 I 나왔지? 다음 거 해볼까? I32. 하늘아, 이거 풀었어?
이것도 I 나왔는데 저는
그냥 I?
네.
다른 사람들도 다 I 나왔어? 아니면
궁금한 게 있는데 remainder가 안 나오면 그냥 i죠.
생각해보자. 그래서 remainder가 없으면 뭘까? 예를 들어서 I16 해보자. 16 divided by 4 하면 그냥 4 나오지. remainder가 없잖아. We know that I to the fourth is 1, right? So what is 16? I to the 16th is the same as I to the fourth times I to the fourth times I to the fourth times I to the fourth. 이게 1이면 1 곱하기 1 곱하기 1이네.
Oh.
1, right? So if there's no remainder, it's the same as 1. So I to the 32 is just going to be 1, not I. Does that make sense to everyone?
Yeah.
Yeah, hopefully that made sense. Let's move on. I to the 45th power. What do you think that is? 예지야, 이거 풀었어?
네.
답 뭐 나오는지 알려줄 수 있어?
I.
Just I? Oh,
Yeah, just I.
just I?
Yeah.
Did everybody else get just I?
Yes.
Okay, let's move on. I to the 56th. 지원아, back to you.
I got 1.
1.
Mm-hmm.
Okay. Everybody else got 1 too? Right? Okay, cool. Let's do I to the 11th. 설리나, 이거 뭐 나왔어?
Negative I.
Negative I. Did everybody else get negative I?
Yes.
Okay. It seems like everybody else did. And finally, I to the 123rd power. 시우야, 이건 뭐 나왔어?
Negative I 나왔어요.
Negative I? Did everybody else get negative I? Okay. You guys did pretty good on this one as well. Let's move on to the next section of the homework, which is graphing complex numbers. Graphing complex numbers. So we have a graph where our real numbers are here and our imaginary numbers are here. Our first question is 3 minus 4i. 3 minus 4i. 민혁아, 이거 풀었어?
네.
어디쯤에 있어, 포인트가?
X가 3고
X가 3고, 그치?
Y가 Y가 4, negative 4.
Y가 negative 4, 그치? 그럼 한 여기쯤에 있겠지? X가 3고, 하나, 둘, 셋. Y가 negative 4. 하나, 둘, 셋, 넷. 여기쯤에 있을 거야. 다음 거 해보자. 1 plus 3i. 1 plus 3i. 하늘아, 이거 해줄 수 있어?
X가 1,
X가 1이고,
Y가 3.
Y가 3. 여기쯤에 있겠지? 쉽지 이건. 빨리 해보자. Negative I. 예지야, 이거 해줄 수 있어?
I'm not sure, but is X 0 and Y is negative 1?
맞아. 여기야. X 0. It's the same thing as 0 plus negative I, or 0 minus I. So we don't move at all, and we just go down 1. That's right. That should be bigger. That should have been Not that bad. Let's move on. Let's see, our next topic is multiplying complex numbers. So I'm guessing it was a bit difficult from here. Let's try some of the problems. Our first problem is 3 minus 5i multiplied by 4 plus 2i. 지원아, it's back to you, I guess. 이거 뭐 나왔어?
I got 22 minus 14i.
22 minus 14i. Did everybody else get that?
I got 12 minus 14i.
12
Oh.
minus 14i?
Wait, did she
Oh, shit.
say that also? Oh.
I think she said 22, right? Let's try this one together. 3 times 4 is 12. Negative 5i times 4 is negative 20i. 3 times 2i is positive 6i. And negative 5i times 2i is going to be negative 10i squared. If we simplify, 12 is just going to be 12. Negative 20i and 6i is going to simplify to negative 14i. Can anybody tell me what this simplifies into?
Negative 1, so plus 10.
Negative 1 plus 10, right? So positive 10, just positive 10, because it's negative 10 times negative 1. So 12 plus 10 is going to be 22, and we can't simplify negative 14i.
Oh.
That should be your answer. It might have been a bit difficult. 22 minus 14i is the correct answer. Let's do the second problem. It's 7 minus 2i multiplied by 3 plus 4i. 설리나, 이거 풀었어?
네, 29 plus 22i.
29 plus 22i. Did everybody else get this too?
Yes.
Yeah? Negative 6. Okay, if everybody else got that, there's no need to solve. Okay. Let's move on to the next one. The question is 1 plus 6i times 3 minus I. 시우야, 이거 풀었어?
7 plus 21i.
7 plus 21i. Did everybody else get this? Apparently everybody else got this.
What, I think I got a different answer.
Oh, okay. What did you get?
I got 9 plus 79.
9 plus 79. Any other different answers?
I also got 9 plus 79.
Okay, let's try this one. 1 plus 6i times 3 minus I. If we multiply this, we get 3. Inside is going to be 18i. Outside is going to be 1 times negative I is just going to be negative I. And 6i times negative I is going to be negative 6i squared, right? If we simplify this, 3 is going to be 3. 18i minus I, that's going to be 17i. And this is going to be, anybody?
Plus 6. Positive
Plus
6.
6, right? So 3 plus 6 is going to be 9. And we're left with 17i. So 9 plus 17i is correct. Let's move on. The next question is 3 plus 4i times 2 plus 3i. 민혁아, 이거 뭐 나왔어?
이거 negative 6 plus 17i.
Negative 6 plus 17i. Did everybody else get this?
Yeah.
Nice. Okay, let's move on. 7 plus I times 2 minus I. 하늘아, 이거 뭐 나왔어?
15 minus 5i.
15 minus 5i?
Yes.
Okay. Did everybody get this?
Yep.
Okay. And moving on. 8 minus 4i and 2 plus 6i. 예지야, 이거 마지막 거 해줄 수 있어?
Is it 40 plus 40i?
40 plus 40i. Did everybody else get this too?
Yes.
Okay, nice. Solving quadratic equations, complex solutions. This was probably the hardest. Let's try problem number 1. We're given 3x squared plus 5x plus 9 equals 0. 지원아, 이거 뭐 나왔어?
I'm not sure, but I got x equals 5, negative 5, plus or minus root negative 83 over 6.
Negative 83 over 6.
Yeah.
Okay. Anybody else? Did everybody get this?
I made the negative 83, the
I,
I and
right?
80. Yeah.
Yeah, that's an important step. You have to take the negative I out. Other than that, did everybody else get this?
Yes.
Okay, nice. Let's move on. The next problem is gonna be 5x squared minus x plus 4 equals 0. 설리나, 이거 뭐 나왔어?
X equals 1 plus or minus I square root 79 over 10.
Okay. Did everybody else get this too? I'm going to take the silence for a yes and just move on. By the way, if you guys don't talk, I don't know if you got it right or wrong, and we can't really go over it. So if you just stay quiet, then we'll just go over it. I'm going to assume you got it right. And the next problem is x squared plus 3x plus 1 equals 0. 시우야, 이거 뭐 나왔어?
잠깐만. Is
괜찮아,
this?
good.
Oh, okay. I got negative 3 plus or minus root 5 divided by 2.
Negative 3 plus or minus root 5 divided by 2.
Mm-hmm.
Did everybody else get the same answer?
Yes.
Okay. 3 more questions. 7x squared plus 2x plus 1 equals 0. Let's go with 하늘이. 이거 뭐 나왔어?
X equals 8 plus or minus square root of 80 over negative 8.
Like that? Wait. 8 plus or minus square root of 80 over negative 8?
Yes.
Okay.
I got different.
Okay. Did everybody else get this answer?
I got a different answer.
Oh, wait. Sorry, I gave you the wrong answer. It was the next
Okay.
one.
That's for 23.
Okay, that 23. We'll just disregard that then. What did you get for this one?
2 plus or minus
2 plus or minus, wait, what? Could you say that
I.
again?
Yeah,
I, okay.
I square root of 24
Square root of 24
over 14.
over 14. Did everybody else get the same answer?
I got -2.
You got -2 plus or minus I. Right?
Yeah.
Okay. Let's try this one then. Quadratic formula is going to be x equals -b plus or minus square root of b squared minus 4ac all over 2a. We know that in our equation, that's b, that's c, and that's a. I'll just label that. X equals, b is 2, so x equals -2 plus or minus 4 minus 4, 7 times 1, right? All over 2 times 7, which is gonna simplify to negative plus or minus. That's going to be 28. 4 minus 28 is going to be -24 all over 14. You can take an I out because of the negative. -2 plus or minus I over 24 and 14. We're not quite done yet though, because we can still simplify this. Does anyone know how we can simplify 24 again? How do you think we can simplify this? Okay, well, 24 is the same thing as 4 times 6. And we know that 4 times 6, oh my. We know that 4 times 6 is 2 times 2, right? So if we rewrite this as -2 plus or minus I times the square root of 4 times the square root of 6 over 14, this is just going to be 2, right? So -2 plus or minus I 2, or 2i, I times 2 times square root of 6 over 14. 2, 2, and that can cancel out to be 7. So our answer is going to be left with -2 plus, never mind, -1. -1, I'll rewrite it here. -1 plus or minus I square root 6 over 7. Remember, we have to simplify our radicals. Other than that, I think that's it. Moving on. Let me just erase this. Our next problem is going to be -4x squared plus 8x plus 1 equals 0. 예지야, 이거 뭐 나왔어?
I got -2 plus or minus 1 over 2.
-2 plus or minus 1, just 1, over 2. Okay.
Yeah.
Did anybody else get a different answer, or did everybody get this?
I got x equals -8 plus or minus Square root 80 divided by negative 8.
Divided by negative 8. Okay. So everybody got either this or this, right? Let's try this one together. X equals, I'll do this straight from the quadratic formula. Negative 8 plus or minus 64 minus 4 times negative 4 plus 1 over 2 times negative 4. So let's simplify. Negative 8 plus or minus, this becomes positive 16. So 64 plus 16, which is gonna be 80. 80 all over negative 8. We're not quite done yet though. Let me rewrite that. 80 is the same thing as 4 times 20. 20 is the same thing as 4 times 5. So essentially, we can rewrite this as negative 8 plus or minus square root of 4 times square root of 4 times square root of 5 all over negative 8. 4 and 4 is just gonna equal 2. So we know that the answer is negative 8 plus or minus 2 times 2 is gonna be 4 square root 5 over negative 8. We can simplify 4 again, leaving negative 2 plus or minus 1, just 1, or square root of 5 over negative 2. The negatives cancel because negative 1 over negative 1 is going to be positive 1, right? So we can just write 2 plus or minus square root of 5 over 2.
So you don't need to put 1 after plus or
After
minus?
a radical, like that?
Yeah.
No, you don't have to do that.
Oh.
It's the same thing as like writing 1x. You just write x. It's the same thing. You can write it, it's not wrong, but yeah, you usually don't write it. Does everybody understand that?
I have a question.
Uh-huh.
So, like the 80, like you split it into 4 and 20.
Uh-huh.
So like, can you split it into like different number, such as like 8 and 10?
Yeah, you can also split it into 8 and 10. If you split it into 8 and 10, however, if I split this into 8 and 10, we're gonna have radical 8 and radical 10, right? But we can't simplify this unless you split 8 into 4 and 2, but we're still left with 2. You wanna split it into numbers that are a perfect square, like 4 or 16 or 25, etc., 36. These are perfect squares, right? So it's better to split it into 4 and 20 rather than 8 and 10. Actually, it would be the best to split it into 16 and 5. But yeah. Is everybody cool on this? Should we move on?
Yep.
Okay. Oh, this is going to take some time. Okay, moving on. Our next problem is our final problem too. 6x squared minus 4x minus 1 equals 0. 지원아, 이거 뭐 나왔어?
I got 4 plus or minus
4 plus or minus
square root of 40
square root of 40
over 12.
over 12. Did everybody else get this?
Yeah, but
Okay,
we have to simplify it, right?
right. Good catch. So 40 is the same as, what should we divide this into? What do you think would be some good numbers to divide 40 into?
4.
4 and 10. That's a great option. Let's try that. X equals 4 plus or minus square root of 4 times square root of 10 all over 12. 4, square root of 4 is 2. So 4 plus or minus 2 square root of 10 over 12. We can take out divide by 2 for the whole thing, and we're left with 2 plus or minus square root of 10 over 6. Does that make sense? That should be
Yes.
it with our homework. Hopefully, I guess it was pretty hard, the last part, but other than that, I think you guys did a great job. Let's go over our homework, our lesson, and we're gonna do factoring. Factoring. Everybody, do you guys know what factoring is? Right? Factoring. It's pretty simple. Let's start with factoring monomials. Factoring monomials. If I wanted to factor 36x8, and I knew that one component was 6x to the 5th, but I don't know what the second component is. What do you think this would be? Does everybody?
6x3
6x
to
the
the
third
power
power, right?
Yeah.
Yeah. So this is basically called factoring. We're not distributing, but it's the opposite of distributing. We're dividing. We see here that 6 times 6 is going to be 36. 6 times 6 is going to be 36. X to the 5th times x to the 3rd is going to be x to the 8th. So we're basically left with the same thing. So let me erase this. So let's try another problem. 72z the 12th. I know that one component is 9z to the second. I know it's multiplied by a. What do you think a is?
8z10.
8z to the 10th, right? Because we know that this multiplied by this is going to give this. Nice. This is pretty simple. We should move on. So when we factor, important thing to know is what you call a greatest common factor. You guys might have heard of this. It's also called the GCF. You probably learn it in elementary school. That's the first time you learn about it. But it's really important in factoring. For example, if I have a list of numbers, let's say 4a squared and another number 12a and a final number 36a cubed. The GCF is the greatest common factor for all three numbers. So let's look at 4a squared. What are our factors? We have 4a times a. We have 4 times a squared. Actually, we should start with something simpler. ignore this. Let's do something like 18 and 48. Our greatest common factor. So let's start with 36. What is our greatest common factor between these two numbers?
6 and
Sure.
6. Wait.
6 times 6, okay. Well, first let's start with 1 times 36. There's 2 times 18, 3 times 12, 4 times 9, 5 we can't do, 6 times 6, or let's just write 6. And I think that's it. Right, I think that's it. So those are all our factors for 36. Let's see what all our factors for 18 is. There's 1 and 18, 2 and 9, 3 and 6, and I believe that is it. 48, let's see. There's 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8, 10, 12. Oh, we already did 12 and 4. I think that's it too. So our greatest common factor is the highest number that is common to all of these. These all have a 1, but that's a really low number, right? We want the highest number that's common. They all have 1. Let's see. Let's try 2. They all have a 2. This doesn't have a 2, so that's not a common factor. Let's try 4. 4. This guy doesn't have a 4, but that can't be a common factor. 6. 6 is here, 6 is here, 6 is here. Okay, so that's a new common factor. That's another common factor. And I don't think anything else duplicates, right? Except 6. So 6 is our greatest common factor because 6 is the highest number that factors from 36, 18, and 48. Does that make sense?
Yes.
Hopefully
Yes.
that does. Okay, what if we have variables? When we have variables, it's basically the same thing. What do you guys think the greatest common factor between these three numbers is?
4a.
4a, that is correct. 4a is the biggest thing we can factor from this, this, and this. I think you guys are catching on pretty quick. Let's try something else. 12z squared, 6z, and let's try 18. What do you think the greatest common factor is?
6.
6, right? Just 6. We can't do z because there is no z for 18. Yeah, so that's what a greatest common factor is. So how can we use this in factoring, right? Factoring by a common factor. It's essentially the same thing. If I told you to factor, for example, 4x cubed plus 12x, we want to get that greatest common factor for these two variables. What do you think the greatest common factor is?
4x.
4x, right? So we can factor out a 4x, which leaves us x squared and 3, just 3, because 4x times x squared is 4x cubed, 4x times 3 is 12x. That makes sense, right? You can also divide 4x cubed divided by 4x. It's gonna be x squared. if it's hard to find what this number is. Let's try another example. I told you to factor 36 z squared minus 2z plus 18z cubed. What's our first step? Our first step is finding the GCF, right? What's our greatest common factor between these three terms?
2z.
2z, nice. 2z. And then all we have to do is just factor. 2z, what's our first term? If we take out a 2z.
18z.
18z, nice. What's our second term?
-1.
-1, nice. And our final and last term?
9z squared.
Positive 9z
Yeah.
squared. Nice. And that's all we have to do. That's how you factor, by a common factor. But obviously, if that was it to factor, it would be a bit too easy. So there are different types of factoring. Factoring high degree polynomials. Do you guys know what factoring by grouping is? Let's try one example. X cubed plus 7x squared minus 5x minus 35. If I told you to factor this, if we try to look for a GCF here, our highest GCF is 1, which doesn't really help, right? We can't factor out a 1. We're just left with the same thing. So we have to look for other ways of factoring. One method of factoring is called factoring by grouping. Factoring by grouping. So what you want to do is you factor the two highest terms, by each other. So you factor this and you factor this. These are the two lowest terms, right? And these are the two highest terms. Because this is a 3, this is a 2, this is a 1, this is a 0 here. So what can I factor this, just this by itself? I can,
Maybe.
right?
Yeah.
Yeah, I get x squared times x plus 7, right? Okay, can I factor this?
Yes.
Yeah, I can, right? I want to take out a -5. So -5 is going to be my factor. If I take out a -5, I'm left with x plus 7. Oh shoot, we have an x plus 7 here and an x plus 7 here. So what you do is you can rewrite this as x squared minus 5 times x plus 7, right? Because essentially, if we go this way, if we go the opposite way, we're multiplying x squared times x plus 7, the whole thing, and -5 to x plus 7, right? X squared times x plus 7, -5 times x plus 7. So if we have this, we're not quite done. We're almost done. What else do you think we can factor from this? Actually?
No.
No, we're not going to do hard factoring. Let's just leave the answer like this because, yeah, that's going to be our answer. X squared minus 5 and x plus 7. Does this make sense to everyone? How we rewrite this into two binomials?
Yeah.
Right? let's try another type problem. This is a bit more easier. X squared is x minus 6 and 2x squared plus 4x. If I told you to factor this, well, this is already a bit factored, right? Let's try to factor this. Can we factor this? We can. Two binomials. It's going to be x plus 3, x minus 2. Oh, I should say, does everyone know how to factor binomials? Yes? No?
I don't know.
Oh, you
Not
don't?
really.
Okay. Should have gone over this then. How you factor binomials? It's a bit difficult to learn at first, but once you get the hang of it, it's honestly quite satisfying. So let's take an example. Plus 3x. Let's see. I'm trying to think of an example that fits out perfectly. Plus 2. Okay. So how you factor a binomial is you split it, a trinomial, you split it into two binomials. So we know that x times x, something times something is going to be x squared, right? So x is going to be x squared. Our last term, we know that 2 times 1 has to become 2. So plus 2 plus 1. Our first terms always has to equal their first term, and our last terms always has to equal the last term. The hard part is how do we get the middle term right? Well, in this example, it's pretty straightforward. Our first terms match. So our middle terms just actually match to be the 3x. So 2 times x is 2x. X times 1 is just x. So we get a 3x. So this is a pretty simple example. But what if there was a harder example? Let me give you a more harder example. Factor. Let's try x squared plus 8x minus 3. Into two binomials, right? Our first term is always gonna try to match the first term. So x and x. Actually, this is a bad example because it's the same as last time. Oh, we need a squared plus 8x plus 15. Okay. Our first terms is going to be x. And we know that this term and this term also have to become 15, right? Well, 15, we can 5 times 3, we can do 15 times 1. But we want the middle term to be 8, right? So if we look at the terms that we're dealing with, 15 times 1, do you think there's like any way to for this to become 8? Not really, right? But if we get 5 times 3, if we add 5 and 3, it can be 8, right? So let's try 5 and 3. So if we put 5 and 3 in for this, and since it's a positive, it's positive and positive, we know that 5x and 3x is going to be 8x. So our middle terms line up. It's a bit difficult when our coefficient is changed. What if I told you to factor 6x squared plus x minus 2? So our first terms has to equal this, right? Our first terms. But we can do 3x times 2x, or we can do 6x times x. How do we choose what to do? Honestly, at the first point of factoring, we don't really know. Let's just guess 3x and 2x. Let's try that one first. -2, it has to be 2 times -1, right? But how do we know if the 2 goes here and the -1 goes here? Like that, or if the -1 goes here and the 2 goes here. Let's look at the numbers. If we, for example, put 2 and -1, then 2 times 3x is going to be 6x, -1 and 2x is going to be -2x, and with 4x. And we want an x. That doesn't work. So that's not right. We have to try again. Let's try -1 here and 2x. I mean +2 here. 2 times 2x is 4x. 3 times -1 is going to be 3x. We're given x. That's what we're looking for. So our answer is this. It's a lot of try this. If it doesn't work, try something else. But in the end, hopefully you can get an answer. If whatever you try it doesn't work, then that means you can't factor the trinomial. Hopefully, do you get how to factor trinomials now?
Yes.
Yes.
Okay, hopefully that made sense. So, oh no. If you try this, our first term has to be something times something equals x squared, right? The only thing that works is x and x. So let's write that down first. -6, what works? 3 times -2, or it could be -3 times 2. Let's try 3 and -2 first. Actually, yeah, let's try 3 and -2 here first. When we multiply 2x, and 3x times 2 is going to be 3x, and we're given x. Oh, so we did get it to work on the first try, which is pretty lucky. As you get to solve these, you'll see a pattern. So you'll know that it's actually x plus 3 and x minus 2 before you even solve it, because 3 plus -2 is going to be 1. But it takes a lot of practice. And yeah, we can factor this trinomial into this. Can we factor this? How do you think we can factor this?
By 2x.
Right? We can take out a 2x, and we're left with x plus 2. And we're done factoring. That's our answer. We can't really factor anything else. The final thing I want to cover is factoring by substitution. These are special. These are special cases, I guess. Special cases. For example, what I mean by that, our first lesson we covered, if I multiply x plus 5 squared, I'm gonna get x squared plus 10x plus 25, right? If I multiply x plus 3, x minus 3, this is another special case. We get x squared minus 9. We don't have a middle term. So these are what we call, I don't know if we call them special cases, but they're special types of polynomials. So we can use these to see patterns in big polynomials. For example, x minus 5 squared plus 2y cubed times x minus 5 plus y6. This looks really, really complicated and big, right? But essentially what this is it's the same thing as ax squared. No, not this. It's essentially one of these three special cases: u plus v squared, u minus v squared, or u plus v and u minus v. It's one of these three, this whole thing. Our u and v are going to be these products, but square rooted. So our u is going to be x minus 5. We don't want this squared. And our v is going to be y cubed. And essentially, it fits one of these three things if we plug it in. So how do we know which one it fits, right? Well, we know that if it's plus and minus, there is no middle term. So it's not this one, because we do have a middle term here. So it's either going to be this one or this one. If we look here, it's a if we look here, our middle sign is positive. And if we multiply u minus v squared, we're left with a negative middle term. So our answer is actually this one. We said that u is x minus 5, v is y cubed. So our answer is x minus 5 plus y cubed squared. Does that make sense? Because that's our u, that's our u, that's our v. This is actually pretty complicated. So it's fine if it didn't make sense. Does everybody understand how I got that? Or should I try it? Oh, what was that? Should I try another example?
Yes, please.
Okay. Let's try something else. Let's try x plus 3 squared plus 14, x plus 3 plus 49. So we don't care what the middle term is. Our very first step is to look at the first and last terms. Our first and last terms are perfect squares, right? So what I mean by perfect square is if I do that, we get an answer with no remainder. You get this for this, and we get 7 for this. And those are going to be our u and v values. So our u value is the first term, and our v value is the last term. So if we square it, so our u value, once we square it, is going to be x plus 3, and our value is going to be 7. Does everybody get how I got u and v values? Let's just start slowly.
Yes.
Right? Okay. So once we have our u and v values in place, the next step is to figure out which one it is. So it can be either u plus v squared, u minus v squared, or u plus v times u minus v. Here, in this case, you shouldn't have a middle term. If I multiply it out, you'll see why. You see, u times u is u squared. U times v is positive uv. U times negative v is negative uv. V times negative v squared. Times negative v is negative v squared. Negative uv and uv cancel out. So we don't have a middle term with this condition. And we do here. So it can't be this option. So we're either left with u plus v squared or u minus v squared. Here, we just look at the middle term sign. It's a positive sign. And like I showed before, u plus v squared is the only, u plus v squared is the only way we can have a middle positive sign, because this is going to be 2uv plus v squared positive. If we multiply this out, it has a negative 2uv. So our answer is we just plug it in this equation. So our u was x plus 3. So u, instead of u, we write x plus 3 plus, and our v is 7. And don't forget the square. And that's how we factor something as complicated as this. Does that make more sense? Or are you guys still lost? Nobody? That's our final thing we're going to cover. Hopefully that made sense. Okay. This is some hard stuff, so if it doesn't make sense, you can just say. But okay, I guess you guys are gonna do fine on the homework then, hopefully. That's it for today. I hope you guys have a great dinner. And
Thank you.
thank you.
Thank you.
Goodbye.
Thank
everybody.
you. Thank you.